All right, we have another problem where we're asked to compute the correlation coefficient for a two-variable data set. So here's the situation. We got two-variable data for 6 counties. 6 counties. X represents the number of forest fires this past year in the county, and Y represents the number of rainy days this past year. So X is the number of fires, Y is the number of rainy days. So to find the correlation coefficient, you want to do some things here. You want to calculate something called the XY column first of all. How do you find the XY column? You multiply the X's with the Y. So what's X times Y here? If I take 5 times 46, I'm going to get 230. 8 times 38, I'm going to get 304. 12 times 32, you get 384. 15 times 35, I'm going to get 525. 19 times 20, 380. And 24 times 17 is 408. Now, why am I doing this? Well, I'm going to have to find this thing called SXY, right? Which you take the X's times the Y's, add those up, and then you subtract the sum of the X's times the sum of the Y's divided by n. So what I'm going to do here, I'm going to make a little summation symbol, and I'm going to sum across each of these columns. So in the first column, when I add up those X's, 5 plus 8 plus 12 plus 15 plus 19 plus 24, I've already done that myself. It gives you 83. When I sum up the Y's, oh, that's the wrong color. Should be red, right? 83. When I sum up the Y's here, 46 plus 38 plus 32 plus 35 plus 20 plus 17, I've already done that. It's 188. When I sum up the XY's, I've already done that. 2,231. So to find SXY, we're going to take the sum of the XY's, which is 2,231, we just calculated in the box, minus the sum of the X's, 83, times the sum of the Y's, 188, divided by n. Now, what is n? Oops, let me go back. N is going to be, let's see, 1, 2, 3, 4, 5, 6, right? We had 6 counties. So that's 6 data points. So I do that in calculator. Let's see, I'm going to have SXY. It's 2,231 minus, here goes, 83 times 188 divided by 6 is going to be 2,600.7 roughly, approximately. So the sum of SXY is 2,231 minus 2,600.7. It's going to give me minus 369.7. No, I didn't write it down right. Let me try that one more time. Minus 369.7. Okay, so the next thing I'm going to find is the SXX. So to find the SXX, I'm going to need to create a x squared column. Remember, the formula is the x squareds added up minus the sum of the x's squared divided by n. So let's see if we can get the x squareds. The x squared, so this should be like an orangish color. Doesn't look like an orange, does it? Let's make it more of an orange here. This is supposed to be an orange right here. So we're going to add, well, we're not going to add, we're going to square these guys. So 5 squared is 25, 8 squared is 64, 12 squared is 144, 15 squared is 225, 19 squared is what, 361? 24 squared, I don't remember what is 24, so let me check. 576. So I'm going to add all these up, the x squareds, and I've already done that in advance. It's 1,395. 1,395. Okay, so when I'm finding SXX, I'm going to take the sum of the x squares, which we just calculated. 1,395 minus the sum of the x's, which was 83. We're going to square that and divide by n is 6. So SXX is going to be 1,395 minus, let's see, 83 squared divided by 6 is 1,148.17 roughly. So subtract those numbers, 1,395 minus 1,148.17. It's about 246.83. Yeah, let's do SYY. SYY. That's going to be the sum of the y squared minus the sum of the y's all squared divided by n. That should have been a yellow n there. Okay, so let's find the y squared column. Let's come up with the y squared column. How do we come up with the y squared column? Well, you're going to take the y's and square them. So let me see, 46 squared. I don't know what that is. 2,116. 38 squared is 1,444. 32 squared is 1,024. 35 squared, what is 35 squared? 1,225, 1,225. 20 squared is 400. And lastly, 17 squared is 289. Hey, I even knew that one. So now I'm going to add up the y squares. I've already done this somewhere in advance. Let me see. 6,498. Just be in my box right there, the sum. So we're finding SYY. SYY, let's see if we can write that down. SYY. It's the sum of the y squares, which is 6,498 minus blank squared over 6 here. 6. Right, n is 6. There are 6 counties we're dealing with, 6 data points. Now, what is the sum of the y's? The sum of the y's is that green number back here, 188. So when you calculate this, let's see, you have the sum, SYY is 6,498 minus, let's do 188 squared divided by 6. It's 5,890.7 roughly. So when I subtract 6,498 minus 5,890.7, I get 607.3. Okay, so we got our 3 important numbers, SXY, SXX, SYY. Now we're ready to find the correlation coefficient, right? R is SXY divided by the square root of SXX times SYY. So let's plug those numbers in. Negative 369.7 divided by the square root of, that's a square root symbol right there, 246.83 times 607.3. Okay, that should be like a green color. Or what color is that? Baby blue, I don't know. 607.3. And make sure your square root goes all the way over top of that denominator. Okay. Here we go. Calculator time. Negative 369.7 divided by the square root. 246.83 times 607.3. So I'm going to get a negative, I'm going to go 4 decimal, negative 0.9548. So I got a negative coefficient, negative correlation coefficient. What else do I want to ask? That was number 1, find the correlation coefficient. Number 2. Are the variables directly? Okay, it's not showing. There we go. Directly or inversely related? Well, because it's a negative coefficient, inversely, right? Since the correlation coefficient R is negative, then X and Y are inversely related. Number 3, is it a strong or a weak? Strong, a weak, or a moderate correlation? How strong is the correlation? What is the strength? Let me put it that way. What is the strength? So if you had a 1 or a negative 1 correlation, 1 or negative 1, that would be perfect. If it were between 0.7 and 1, or negative 1 and negative 0.7, it would be strong, right? Hey, this is between negative 1 and negative 0.7. It's still strong, still strong. It is strong.